Hello everyone, JCE Connect series of lecture. In this particular lecture, I will be taking one more example on simple slab base plate for a column. That is a design example. In previous class also, uh, I have taken one design example and I have solved. So in this particular lecture also I am taking one more design problem, and this design problem I have taken from the university exam question papers, and this type of problem generally will be asked for 15 to 20 marks, complete design problem. Uh, Here the design problem given as design a slab base for a column ISHB 300 at 58.8 kg per meter subjected to a service load of 1500 kilonewton. The grade of concrete for pedestal is M20 and SBCF soil is 180 kilonewton per meter square. Design a slab base with welded connection. So this is the design problem given. So you have to follow the simple steps given earlier. The first step you need to do is calculate the bearing strength of the concrete. You have to calculate the bearing strength of the concrete, and as per the code IS 800 2007, IS 800 2007, it is given in a code that is bearing strength of the concrete to be taken 0.6 times of FCK. That is 0.6 into 20. 20 is the M20 grade concrete is given. For M20 20, that is FCK is value 20, then you will get the permissible bearing strength of concrete will be 12 Newton per millimeter square. This much is the permissible. Then next step is you need to calculate the required cross sectional area of the slab. So area required will be the factored load out of the bearing strength of the concrete, and the load given here is a service load. The load given is a service load. You have to make it factor, multiply it by 1.5, then divided by bearing strength of the concrete. You will get the area required is 1,87,500 millimeter square. Then next will be what? After getting the area, then select a suitable size of the base plate. You have to select a suitable size of the base plate based on the area required. Whatever area you have calculated, based on that you have to choose the correct size of the base plate. For that, first you need to take the properties of the ISHB 300 at 58.8 kg per meter from the steel table. So this is the section. This represents depth of the section. This is the width of the section, that is the flange width, thickness of the web, and thickness of the flange. And you have to refer steel table. From the steel table you have to get the properties. So here given ISHB 300, there are two sections here. ISHB 300, you can see here ISHB 300 and ISHB 300, but the weight differs here. One is having a weight of 58.8 kg per meter, another one is a 63 kg per meter. But in our case, the section given here is, I'll show you, the section given here is ISHB 358.8 kg per meter. So that section only you have to refer in the steel table. ISHB 300, that is 58.8. This section you have to refer. Two sections are here, ISHB 300, ISHB 300, and weight will be differing here. One weight is 58.8, other weight is 63. But in our problem, the weight per meter is given 58.8. You have to take this section, and this section properties you need to take. Then after taking a properties, so I have taken a properties from the steel table, that is thickness of flange, width of the flange, height of the section, that is the depth of the section only, thickness of the web. So after taking these properties, so let us draw the base plate. So let us draw the base plate and name it length of the plate and breadth of the plate. On this plate, let us keep the I section like this, and just mark the width and breadth of the I section, that is the depth and width of the flange, like this, 300 and 300, and let us mark the projections also on either side longer projections as well as the shorter projection you mark. Longer projection here I have marked as a B, both side B here and A here. Now from this we can write LP, length of the plate will be 300 plus B, that is 2B. Then width of the plate will be 250 plus A that we get. So this you have to write. Then the area becomes length into breadth. Then you substitute here 300 plus 2B plus 250 into 2A. Then whatever the area you have already calculated, that you substitute here, then you get. Then assuming the same projections are to be provided here, just you assume here the projections are same. These projections are same. Just assume it for the calculation purpose. A equal to B. Then when you assume it, when you simplify it, you will get a quadratic equation like this. This you get. Then you calculate the value of A. Then here I am getting 79.36 millimeter. Let's say 80 mm, or you can say it is 100 mm also projections. So here I am taking A equal to B equal to 80 mm. Okay. So this is okay. Calculate projection area. Then once you get a projection, then substitute in the L and B. Already we have taken L as a 300 plus 2B and B as a 250 plus 2A. Substitute here, you will get 460 and 410. You can take directly 460 by 410, or you can increase it by 500, or you can increase it by 450. So the purpose of increasing is, and later when you calculate the bearing pressure on the concrete pedestal, that can be measured. As the area get widens, the pressure decreases. Okay, or else you keep as it is and check the bearing pressure. Let us provide the same base plate size 460 by 410 mm. Then you calculate what is the actual bearing pressure is acting on a concrete pedestal when you have taken the actual area of the base plate. This is the actual area what we want. This is the actual area we have got. Then that taking that actual area, that load coming on the pedestal, that is 1.5 into 1500 is service load, 1.5 are taken as a factored, then into 10 to 3 here taken W dash is the actual bearing pressure acting, that is divided by 4. Load by area gives you stress or the pressure. 460 into 410, I am getting 11.93. But what is my permissible bearing pressure? Permissible bearing pressure is 12 Newton per millimeter square. Since it is almost near to the 12 millimeter square, okay, so it may fail at any time. Just what you do, you increase the size of the base plate. So here I told you may increase it to 500, or you increase this one as up to 450. Now I increase the base plate since it is almost nearer to the 12. So you just take the safety factor, just you increase the size of the base plate, take 500 by 450 mm, that is a revised one. Then you calculate what is the actual bearing pressure. Now I am getting actual bearing pressure W dash as 10 Newton per millimeter, which is less than 12 Newton per millimeter. Hence this is also correct, but it is almost nearer since I increase the base plate on safer side. Okay, so after increasing the base plate, now I can say hence it is safe. The next step is what? Calculation of minimum thickness of base slab. Okay, so it is given in a clause 7.4.3.1 in IS 800/2007, page number 47. If you refer there, you will be getting the direct formula for calculation of thickness of base slab. This is given as 2.5 W dash. W dash is the actual bearing pressure acting on the concrete pedestal into bracket A square minus 0.3 B square into gamma m divided by Fy. It should be greater than thickness of the flange. If it is coming less than the thickness of the flange, provide the thickness of the flange. Then after substituting all the values here, I am getting 22.19, which is greater than thickness of the flange. Hence say 23 millimeter. Hence provide a base plate size 500 by 450 by 23. This is the final size. So once you get this one, now you have to do the design of weld. So I need to do the welding here for this one. Okay, to weld this one, this column on the base plate, just to mark here 300 by 250. Assume the size of the weld S equal to 8 mm. Initially I am assuming this one size of the weld. Then calculate the thickness. Then what is the length of the weld available along the periphery? Means here I do weld, then here welding, then here like this, like this, like this. This is the periphery. So how much length is available along the periphery of the section? First I need to calculate for the available length, then what is the required length I need to calculate. So available length I need to calculate now. Now the length available here, length available, just a minute. We calculate this length available here. This one, this is the length available. I calculated length available, this one here, you can see here length available 2 into 250, 250 this side and 250 this side. 2 into 250 plus 2 into 250 minus 7.6. If you direct this one, you will get the inner side, this one. 2 into 250 minus 7.6, because two side, this side and this side, inner side. Then plus 2 into 300 minus 2 into 10.6. This is 300 minus 2 into 10.6. The available length of the weld is this much is available. Then what is the required length of the weld? The required length of the weld to be calculated, load divided by strength of weld per millimeter run. Then you would calculate strength of the weld per millimeter run. This is the formula, that is unit strength of weld we calculate for 1 millimeter run of weld. What is the strength? I have taken the thickness as 5.6. This is the strength per millimeter run. Then the length required will be the load divided by the unit strength of weld. Then this much is the length required. The weld to be done this much of the length. But the available is this much. We are available is this much, but the required length is this much to take the load of 1500 factored load of 1500 kilonewton, but which is greater than the available length. What you need to do is you have to revise the size of the weld. Just you revise the size of the weld, take 10, 12 like this. So I have got 14 mm size of weld if you provide, so I can get lesser than this one. So now we provide a 14 mm size of the weld. This 14 mm to be provided in 2 runs. Okay, 14 mm size, the thickness I have got. Then after providing a 14 mm of weld, then again once again you calculate what is the unit strength of the weld. This much is the unit strength of the weld I got for a 14 mm size of the weld. Then the length required, I got 1454, which is less than the available length of the weld. Hence provide a fillet weld of size 14 mm. Okay, so this is the check for the weld. This is the design of weld. First I need to calculate what is the length available for the weld. For the available length, what is the required length of the weld I need to calculate. Required length of the weld, I got required length this much for 8 mm size of the weld. Since it was insufficient, then what I had done, the required length was more here and the available length was less. Hence I revised the size of the weld. I have taken the 14 mm. First I calculated by taking 10 mm, then I calculated 12 mm, which was getting more only. Then 14 mm I got this much length, which was less than the available. Hence the size of the weld is 14 mm. Then lastly you have to provide the anchor bolts of size 24 mm by 4 number of bolts on 4 side of the corner. You need to provide the 4 number of bolts, okay, on the corner. Okay. After this one, you have to, next is concrete pedestal design. So here, as I said, 4 number of anchor bolts to be provided here. Here 1, 2, 3, 4. These are the 4 number of anchor bolts. Okay. Then you have to design concrete pedestal. Design of concrete pedestal. So for the design of concrete pedestal, you have to working load to be taken. The load given is a working only. Then the self weight of the footing, you have to take 10% of the column load, that is 10% of 1500, 150 kilonewton. Then what is the total load coming on the pedestal? 1500 plus 150, 1650 is coming. Then what is the area required for the concrete pedestal? Load divided by SBCF soil. Load divided by SBCF soil. Okay, SBCF soil is given, take 180. 1650 by 180, I am getting 9.167 meter square. That much area of concrete pedestal is required, assuming the square base for the concrete pedestal, or provide a square base for the concrete pedestal. Then L equal to B equal to root of 9.167. Then I got 3.02 meter. Hence provide a concrete base of size 3.02 meter by 3.02 meter. I hope you understood this one. Okay. After getting a concrete pedestal, then what is the depth of concrete pedestal required? Depth of concrete pedestal required. Then you draw it. See, here I drawn 3.02 meter, and this is 3.02 meter length into breadth. 3.02, 3.02 on this concrete pedestal. This is a concrete pedestal. This is a concrete pedestal. On this concrete pedestal, the base plate is kept like this, and this base plate is anchored by anchor bolts, that is 4 number of 24 mm, 1, 2, 3 on 4 corners, and this is I section kept, and for this I section the weld is been done like this. This is welded, and this column ends are machined perfectly like this. It is welded all around. Okay, it is welded. Now mark the 500 by 450 here. This 500 and 450. This is the section of the concrete pedestal. This is the load coming on the base plate. This is the base plate kept on the concrete pedestal of size 450 by 500 on one. This view I taken, this side view. When you look from this side, you can see this 450 mm, and also you can see the concrete pedestal of size 3.02 meter. And depth, let us take a D. We don't know this depth, and this 450 side I am taken. Then the load coming on the plate, then plate to the pedestal, pedestal to the soil. Okay, so this is soil. Now after coming load on the plate, that load is dispersing at an angle of 45. Assuming the load is dispersing at an angle of 45 degree. This load is dispersing at an angle of 45 degree. 45 degree, 45 degree. And this is a 3.02. See, 3.02 minus this is 450, that is 0.45 divided by 2. If I do it, divided by this offset and this offset, I get 3.02 minus 0.45 divided by 2. I'll get 1.285 meter. Okay, I have written this 1.285 meter, 1.285 meter here. Now here I taken, assuming the load is dispersing at an angle of 45 degree, then take tan 45, this one, tan 45. If I take opposite by adjacent, I get opposite by adjacent, D divided by 1.285. This 1.2 adjacent is 1.285. Then I'll get D as 1.285 meter. Hence, provide a concrete base of size 3.02 meter by 3.02 meter by 1.285 meter. Then the base plate size is 500 mm by 450 mm by 23 millimeter. So this is the complete design of simple slab base plate for the column. Okay. So this problem again will be asked for 15 to 20 marks. So these problems are very very important for the examination point of view. So please practice this type of problems. Okay, I hope you understood this one. So in next lecture I will be taking a next design problem, that is gusseted base design problem. This is a simple slab base. Then next, when the load coming on the column is very heavy, or the load is involving any moment, in that case the gusseted bases are being provided to take care of that heavier load. Thank you.